Hello and welcome back to part 3 of the CardRPG Scriptable Objects tutorial for Unity. We're going to be working on creating the card manager today, among a couple other things. My name is Krasenstein, and thanks for checking this out. So let's get deep into it. Just to recap what we did in the last one, we actually worked on, in the last part of this tutorial, we worked on a way to create a card data system. And then we actually created 3 cards: Aerial Flip, which lets you defend damage and draw a card, which is going to be 5 defense. We have a 3 defense card as well, and a card called Smack for 2 strength. So we have to figure out how to. So right now we have nothing besides the camera in the scene. So the next part is actually going to be adding in a card manager that effectively reads all of the card information. So the first thing we need to do is we need to create 2 folders in the script section. Just because of organization, you don't have to do it if you don't want to. I like it. The first one, so you're going to right click, create folder. We're going to call this enums, E-N-U-M-S. Basically, enums are a type of way to show or to classify something. So instead of saying if pick equals 3, you could do if pick equals correct pick or incorrect pick, or you could do, for instance, types of different cards, right? So if you needed to set up a card type, you could set up an enum for it. So instead of doing if card type equals 1, you could do if card type equals attack, and you'll see how that unfolds. We're going to do an enums folder, and we're also going to add in a folder called managers. And so that I like to just separate all of the managers that exist in the game's hierarchy into a managers folder. Right, so the first thing we're going to do is we're going to create 2 enums. I believe it's going to be 2 different types of enums. Yep. We're going to create a C# script, and we're going to call this card types. All right, so let's open up the card types. There we go. We're going to remove class, turn it into enum, which is something that's basically part of the syntax. Remove the inheriting, because it does not inherit, because an enum is just a number system. Right? Effectively, when we're doing this, I'll show you how it is a number system, but we're going to basically do none, attack, defense, item, and boost, or buff. You can use either one, and count. Right? Count lets us be able to run through all of these to search for what kind of type a certain card is, because otherwise you can't use a for loop for it, because this is effectively none. You can do none equals 0, right? And attack equals 1. We could do that because this actually means item is 3. See, it says item equals 3. So we were able to actually set that up that way if we wanted to. It does it for us already, so there's no reason. So you have to make sure you just have a comma. You don't have to have it set up like where it's nice and neat like this. It could effectively, if you wanted to, have it like this. So we're going to save that, Control and S. You can use Control and S, Control Shift and S, saves the entire project. We're going to make another enum called, make another script. It's going to be called current turn. Basically, this will specify which turn the game manager is set up. Right, and we'll have that set up. You do that Control comma in order to bring up, right? Because Control comma brings up the fast search here, so you can search current turn, and it brings up the script for it. You could even go into a project. If you go into the project, you can double click on current turn here, or you can click open here. Either one will open the script project. And so we're going to do another enum where we remove the inheritance part there. We remove start and update, and we're going to just include player turn and enemy turn. We don't need the none in the count because it's just going to move back and forth between these. So now that those are set up, we can save that. We're going to go back into Unity as well. We're going to go into the managers folder, and we're going to do a right click, create C# script. We're going to call this card manager. And before we go into the script, we need to actually go into here and make a card manager. right? So we're going to right click, we're going to create empty. We're going to make sure that the X, Y, and Z values are 0, or Z. I don't know how we want to call it. We can call it Z or Z. We're going to hit either click and click once again to highlight the name, or you can always hit F2. F2 will highlight it as well for you to rename it. And you're going to call this Card Manager. We'll drag Card Manager and drop it on. Okay? So now we're going to open up Card Manager. And we can remove start and update, where we'll use it at some point, but I'm not too worried about it. So now what we're going to do is create something called the Singleton Pattern. And what a Singleton Pattern is in Unity, well, it just is a way of establishing that there can only be one of a certain script in the entire scene. So we're going to set up ways to kill other objects that have that actual script if they're found. And you can also set up a way for these objects to move between scenes without having to delete them. So we're going to set up a singleton for the card manager. We're going to do public static card manager instance. Okay. So after we do that, we're going to do a void awake. Now, if you're in if you're in Visual Studio 2017 or higher, or more, I guess, later, whatever the wording is, if you see when you type A, there's a couple method names that already exist in the Unity world. And basically what that lets you do is you can just hit enter on awake, and it automatically pre-fills in the actual awake system. So now what we're going to do here is we are going to do a if instance is not equal to null. The exclamation mark is not equal to, and instance is not equal to this. Then we're going to destroy this .gameObject and return. This basically says if a new scene starts and an object exists already with this script on it, then kill that object or destroy that object. Otherwise, because you're going to return out of that, so it means it'll end it there. So instance equals this, right? So basically this is saying if the scene starts and the object exists, then make sure you destroy the object. Don't let anything else run. If that doesn't satisfy it, right, then turn out instance equals this. So now we have set what instance is. We can now access this script without referencing throughout the entire project, as long as this exists in the scene, right? So now we're going to do a couple things. We're going to set up start. We'll go back in and we'll fill in start, right? So you void start. So I just hit void S and hit start, and it pre-fills it, right? We have a couple more things we want to do. We have a couple, what's it called? A couple variables that we're going to set up here. We have a couple variables that we want to set at the top of the script. I typically put them at the top. You can really put them wherever you want. But I'm going to do something called regions. So you do hashtag region tab, and it asks for what the region name is going to be. We're going to call it variables. What that lets you do is it lets you collapse that area by clicking this little plus sign and minus sign. So that when you type in a bunch of stuff and you want to collapse it because you're not worried about the variables are called, it effectively saves space for when you're scrolling up and down in your script, right? So the first thing is we're going to set up is a current turn. So remember that enum that we created? We created the current turn enum, so we need the current turn so we can see if we can use a card or not, basically. We'll be able to set if current turn equals player, then do this, or if current turn equals enemy, then do this, right? It is a turn-based card game after all. We need to set up we do have to set up the card prefab. So we're going to set up a public game object of the new card prefab. So after we set up the card prefab in the prefabs folder, we'll be able to drop that in. We need a couple more things. We need a couple transforms. Transforms are basically the position, rotation, and scale of an object. So it's easier to reference it when you need to search for a child or need to do anything that has to do with the position. You can call yada yada dot position versus new card prefab dot transform dot position. Makes things a little bit easier, right? The transform draw container, because we're gonna have a draw pile basically. So like the cards will sit here, sit inside this object when in draw pile, right? We'll do another one for the discard container, and that will be the cards that will sit inside this object when in discard pile. Pretty obvious, pretty straightforward, right? And then we need the cards that exist in your current hand, right? So that's the card holder container, card holding container, current hand container, whatever you want to call it, right? And that's the spot on the screen that shows current cards in your hand, right? And look, because of how we set the subregion thing up, we can collapse it completely. We do need a couple other simple things. We already have the card data system created. So because of that, we can set up two different lists. And what those lists are going to do, they're going to be able to, this card's going to be basically pulled from. So we're going to do public list. We're going to make a list of card data, right? And this is going to be current available cards. And we'll do equals new and then hit enter, and it should automatically pre-fill the list for card data. What this is all cards that you currently have in your deck. All right, we'll do another one as well, and this is going to be all cards that can exist in the game. Place any newly created card datas in this list. And that's going to be a list again of card data called all cards that exist. It's a new list of card data, right? We need a couple integers. We have an int for starting hand size. That's going to equal 5. We have another public integer for max hand size, which is equal to 10. Then we need also stamina, because the game exists with stamina. Cards cost stamina, so we need to set up that. So public int stamina at start, which is the stamina at the start of your turn. So that's 3. And another thing for another public integer for current stamina, which is the same as 3 for now, right? Stamina at the start of every turn. Stamina, or your current stamina left current turn. Okay. And amount of cards drawn at start of turn. Cards cannot, your card holder container cannot have more than max hand size as the content, as the child objects. Okay. We have a couple more variables to do. There's not that much more stuff. It is a rather complicated script because it's the manager for the entire card system, right? We do need one thing that we need a bool, which is a true or false statement, called is starting draw. And we're going to set that to false at first, right? Basically what that does, that's going to check to see, hey, is this the starting draw? Make sure we draw X amount of cards that equal the same. We also need to do, up in the very top, we need to type using Unity Engine dot UI. That way we have references to the actual UI. Right, so now we need public text, which is part of that UI library. Draw pile text to show how many cards we have left in the draw pile. How many cards left in draw pile. And then another text of discard pile. And I usually label them with the word text inside the variable so that I know exactly where I'm going, or exactly where it's going. How many cards left in, or how many cards in discard pile, right? Reference to the button that ends your current turn. Public button and turn button. Now up here for these, we're going to set up what's called a header. Well, I'll show you how the hierarchy works first before we touch header. So now after that compiles, we have everything here, right? We have the player turn, enemy turn. We have all of this stuff here. We have the current cards available and current cards exist, but everything's really jumbled together and really difficult to read in here. We're going to split things up a little bit, right? So let's do that just to make it look easier. It's good for your eyes. It makes things easier when you're trying to debug things as well. We're going to do square brackets, header, and then parentheses, and we're going to call the header. We're going to call this all cards in current deck, or we're just going to call it cards in current, right? And then here we'll do another header, and we'll call this all cards in game. So every card that exists, right? You can set other things up too if you wanted to. You could effectively do a header here called hand size, right? You do a header here called stamina, right? And you can do a header down here called UI. And that keeps it really organized, actually. Right? Save that. We go back. That'll show you the new stuff. So we have cards in current deck now. Everything's all split up. It's really easy to read. Like, really easy to read. Right? So, first thing we're going to do is we're going to create something called, okay. So the first thing we're going to do is in start, we're going to have something called load deck, right? We're also going to set is starting draw to true because you want to start, you go first, right? You always go first for your turn. We're going to set up a public void load deck, right? And this happens at the beginning of combat or each enemy. We're going to call that combat. What we're going to do is we're going to actually create a way to instantiate and set it up into a certain thing, right? So we're going to do this. We're going to do a for loop. So you do FOR for for, tab, and that sets up the initial for loop, right? So you can tab through everything that's highlighted. So we have int I, hit tab, you're at length now. You're going to do current available cards. So all the cards you own, .count. We're going to run through all the cards you have, right? And we're going to create a card for each of those cards. We're going to do game object, and we're going to give it a name of G equals instantiate new card prefab, because it's going to be the prefab, and we're going to stick it inside draw container because it asks for a parent. So basically, this draw container right here, cards will sit inside in the draw pile. So every time when the cards are created, they're all going to be thrown into this draw container. Okay. Then we need to do something called a card, which we don't have yet. So we're going to actually do that now. After we set up the rest of the outside stuff, right? You're going to set the card to the card data, right? So card data for that prefab, for the cloned prefab, and then set the card's name in hierarchy. So we're going to do update display, public void update display. For now, we're actually only able to really do drawPile text.text. And that's going to equal to drawContainer.childCount.toString. So it's going to count how many cards exist in the draw container and then show a number. And then we're going to also do the discard pile text.text equals discard container.childCount.toString. Then for tab, and then tab wants to get past the I, get to the length. We're going to do card holder container.childCount. Right? So now we're going to go through all the cards that exist. Right? Basically what this is going to do is this is going to check if you can use each card in your hand and change the color of the stamina cost accordingly. That's how we're going to do it. But that'll be something that we do in the future. Okay. So now also in load deck we need another one called initial draw for turn. Basically this is the very first draw at the beginning of combat. Right? So we're going to do the same thing here where we create a new thing, initial draw for turn. Basically the first thing, this is first time we draw cards each turn. What we're going to do here is we're going to set the current turn. So if it doesn't already equal it to, so the best thing about enums is when you hit equals and you hit space, it automatically chooses it. When you hit dot, it goes current turn dot, and you want enemy or player turn. Well, I want player turn here, right? We're going to change the end turn button dot interactable because it's a button. Make it true, so you can click end turn on your turn, right? We're also going to set current stamina to equal to stamina at the start of turn. Right? And you can always go in and modify that. If you have X relic, you can always add stamina +1. There's a bunch of different ways you can just put pieces of code in to add new stuff, right? We're going to do a to-do here, and that is set up what enemies do on the beginning of your turn, right? We're going to also set up the if statement of card holder container dot child count. So if the amount of cards that exist right now in the current hand is less than starting hand size, then we're going to draw a card. Right, so we don't have draw card yet, but now we're going to draw a card. Right? Otherwise, so else is starting draw is equal to false. Basically, this is saying, so this right here says if the starting hand size is less than, or if the starting hand size is larger than the current hand, then draw a card. Otherwise, don't. And then of course, we'll be also updating the update UI. Well, right? So that's some things we're going to be adding in there. Now what we need to do is we need to add in the draw card. Right? So do public void draw card. The first thing is we have to do a check here. So if draw container, so if the draw container child count, so if this is the basically amount of cards in draw pile, right, is greater than 0, then we're going to do stuff, right? This is then draw the card. Otherwise, if it's right, so otherwise if the draw container dot child count is less than or equal to 0, then we're going to reshuffle, which we don't have this command for yet, or this method, but reshuffle deck. Right, so we'll be adding that in as well after we configure a draw card. If it is starting draw, then we're going to set up initial draw for turn, right? So initial draw for turn. Basically, it's going to keep running through it if the starting draw is still good, right? So it's going to check this, set up the stamina and everything like that. If it's still underneath the hand size, draw the card. Otherwise, turn this off, right? And because it's going through draw card, it will then read through everything here and then set up another draw to see if it draws again. Now, when we draw a card, what we need to do is actually set up this. So we're going to set up a random number. Int r equals random.range between 0 and draw container.child count. So that's going to pick a number between 0 and however many cards exist. So it could be card number 6, card number 9, right? So then we're going to go like this. We're going to go draw container dot get child of position R, so whatever number that is in the sequence, dot transform dot parent. So we're moving where this card sits, right? So it equals now the card holder container, now the owner of this card, this object, right? So that's basically how drawing a card works. Now we do need also to figure out reshuffle deck, right? So the same thing happens down here. Public void reshuffle deck. And basically this is saying, hey, there's no cards left in the draw pile. I want you to take everything you have and toss it back into the draw pile from the discard pile, right? So we do a for loop here. That changes how it is set up. This is actually going to be I is 0. And hit enter, right? You're going to change I is equal to, we're going to do discard container dot child count, child count -1, and I is greater than or equal to 0, and I -1. Basically, this is saying we're starting at the bottom of the list and working our way up so that things don't break, move, and position and stuff like that. So we'll pull number 20 away, then number 19, then number 18, and so on and so forth. So we're going to set up a transform. We'll call this temp card equals discard container dot get child of position I, which is wherever we're at. And we're going to do discard container dot get child I, which we don't need to do anymore because we already have. Oops, we don't need to do that anymore. We can just do temp card. All right. So what we're going to do is we're going to do temp card dot transform dot parent. Right? And where's that going to go? It's going to go in draw container. right? And then we're going to reset the card transform to make sure that it sits at 0, 0 for temp card. Okay? And then, of course, at the very end, you need to make sure the numbers work right, so it's update display. Pretty simple helper function that basically just you do reset card transform. We call a transform of something, transform card, right? And all you need to do is card dot local position equals vector 2 dot 0. That sets the x and y value to 0, 0 in the actual parent object's container. So it goes, hey, wherever this parent object is sitting, it's going to sit in 0, 0 inside there so it doesn't move outside of where it's supposed to be. So we can call that basically every time that anything needs to move, right? So this is the bare bones what we need for the card manager, right? We have all the variables for it, which we can collapse. Boom. Makes it a lot easier to read everything. We have the singleton setup for it. We start the game. We load our deck in. Right, we need to set all the cards still. We need to do that. But we can update the display. We can do the initial draw that checks every turn. We can draw cards. We also have a way to reshuffle the deck to make sure that we don't ever run out of cards. And we have a way to reset transform. It's basically the bare bones of how the card manager works without adding the actual nuances like discarding cards, ending your turn, which we will do in the future. Absolutely. Right? That's because, and drawing multiple cards. Right? So that's how the main, I guess, gumption of the card manager works. So let's make sure we save that. Control-Shift-S is what I do, is what I use to save because it saves everything. We're going to go back in here. Right? We have, right now, I don't even think we have the prefab. We don't have a prefab yet of the actual card because we need to make a card, right? So what we're going to do for this card is we're going to create a UI, a new canvas. The canvas already creates an event system for you. You don't have to worry about event systems. They cooperate themselves. It's fantastic. So a canvas, you're gonna set it up this way, right? We're gonna do a screen space overlay, which is perfect. We're gonna do instead of a constant pixel size, we're gonna do a scale with screen size. We're going to use the reference resolution, which is the one we want to use. It's here. We're using 1920 1080. You can use whatever size you want. And I set the match width or height to 0.5, so it always sits perfectly in the middle of the screen based on the size of the window. Okay? And that's to make sure that all the UI sits correctly. So inside this, we're going to make a new empty. And this is going to be called the card. Okay, so we're going to change the name of it to card. The card is going to be a certain size as well. We'll work on that when you can actually see what it looks like, right? So we need to set up an image. And look, it's a card. So it's actually going to be 200 pixels by 200 units by 250 units. All right, so it would be pixels. Kind of a size of a card, right? We're going to set the anchor to the bottom left. Inside the image, we need a sprite, right? So let's bring in the blank card sprite. Boom! Look, we have a card now. Pretty cool. We make sure to preserve aspect to make sure it stays the same size, does not change. And then we'll also add a button to it as well. So basically, this makes the card clickable. So it'll be a clickable object that always works. Right? So it's interactable. We don't have to worry about normal and highlighted and all that stuff. And that is that. So that's how we're going to save the card. So in order to save the card, we're going to click in, grab it, mean it, pull it into the prefabs, and let go. Boom, we have cards as a prefab. We can now delete it from here if we want it. It's not needed anymore. But hey, we can go into the card manager, and we can pull in the card prefab. We have that now. We still need a couple more things, which we will work on in the next piece of the tutorial, which will be setting up the game UI and attaching all the card stuff to it, and then making the card script. So I hope you guys liked the tutorial. Much appreciated. Thanks for watching, and we'll talk to you guys soon. See ya.